So let's break that down a little bit, okay? Let's give ourselves some rules that we might use to determine how much data we need. So the first thing is for measurement. So measurement data, I need all the measurement points where volumes are required for settlement or for balancing. In terms of speed, like how quick I get the data after I ask for it, several minutes is probably fine. I don't need this data right now. I can tolerate some latency. How frequently do I ask? Pipelines, you know, there are a handful of pipelines that will ask for this data every 15 minutes because they do 15-minute volume totalization. For the most part, 98% of the cases, the data is not even built more frequently than once an hour. So rarely am I going to ask for the data but once an hour. And in a lot of cases, particularly in production fields where my telemetry is not only limited by bandwidth, but also how much battery I can consume transmitting, it's not uncommon to only ask for the data once every 4, 8, once every 24 hours. Because I really just want to know, what did I do yesterday, right? And then this is a big set of data. When I ask for this data, I'm getting the full audit trail. It's a big block of data. And I'm using that data to do things like line pack analysis, volume roll-up analysis, balancing analysis. So the other thing I've got to do is I've got to get all this data time-stamped and put together in a way so that I can have the data available to me to analyze what I'm looking for. So to kind of sum it up for data, it doesn't really need to be real time, but it's a lot of data and it needs to be well organized, okay? What about marketing? What does marketing need to know, or scheduling? What do they need to know? Well, they really just need to know how much for each of these points that I'm moving gas through, all these places I have contracts in place, how much product have I moved so far today, and what does my nomination require me to move today, and can I get there, right? So this data is, timeliness is more important. You know, in the marketing world, you know, I set my nominations up during the day, and then if I'm following the GISB rules, I have several windows through the day when I can revise those nominations. So when I'm doing that, I can still wait a few minutes, but I need the data to get there pretty quickly. I'm probably wanting to see that data every hour. In some places, I may want to be seeing it every 15 to 5 minutes, particularly if I've got, you know, if I'm operating a gas storage facility or several gas storage facilities and I've got a header pipeline on that and I've got a lot of people moving gas in and out, I may want to see that data pretty frequently because it matters, you know, in terms of how I'm able to serve and support my customers. So what about analysis and optimization? So this kind of data, I need lots and lots and lots. Engineers have an insatiable appetite for data. So they want everything they can get as quickly as they can get it at the fastest sampling rate they can possibly get it, because more data is better if you're an engineer. Speed doesn't really matter because I don't care if I wait 2 or 3 days to get the data. I just want a big set so I can, you know, analyze it and crank my numbers and do statistics and fun stuff, right? How frequently do I need it? Often, but not necessarily on any kind of predefined schedule, right? Once a day, once a week, once a month, when I ask for it, that kind of thing. So from a set processing standpoint, it's not uncommon to find some general requirements that are not well defined that are driving requests for lots and lots of data, right? So one of the challenges in terms of optimizing the communications capacity to move the data is really getting clear about what does the engineer need? How often do they need it? Okay? When we start getting to the real kind of hardcore operations safety type data, operations control type data, you know, the game starts to change a little bit. Now I need the data that's critical to operate and the data that's critical to maintain situational awareness. If you haven't heard the term situational awareness before, just interpret that as an understanding of where the process is at, right? A lot of times I don't need a lot of information presented to me to maintain situational awareness, but it's got to be the right data, and when something changes, it needs to be updated quickly, right? So in this case, the data's got to be quick. I'm willing to click and go and take a breath, and then I want my data, right? So speed is of the essence with this kind of data. Frequency, probably never less than once every 5 minutes. Now there may be some places where they're getting data once every 15 or once every hour on the edges of a system where that measurement's not critical. But when you start getting into the core operating area within a system, particularly like in midstream where you've got your fractionation and your extraction and your liquids pipelines all kind of centralized, the data around that, I want it all the time and right now. You want to see an operator's stress level escalate in a hurry? Have somebody that's operating that kind of facility blind for more than about 5 minutes. And you'll see them getting real nervous real fast. So, however, there's really no processing required of this data. I mean, it's just grab it and present it to me. There's not a lot of processing required. From a coordination standpoint, this is generally, so the analogy here, or the operating consideration here is I'm in a control room and I'm calling an interconnect partner, or an interconnect partner is calling me and saying, hey, what's your current pressure at this location? Something that they don't have visibility to, but could impact their system. Like I'm trying to troubleshoot something going on my system, so I call you for information that could help me understand what might be going on. So in that case, we're willing to wait a moment or two, but we're not willing to wait very long. So this data needs to be available on request, needs to be quick, and again, there's not a lot of processing required there. And then there's alarm emergency response. So this is kind of interesting, and really a lot of our systems and a lot of the way we build our HMIs doesn't address this well. There's a technique called the high performance HMI that there's some great resources and books about. But when I start dealing with alarm and emergency response, let me give you an example of this. Excuse me, I gotta pick something up. So if I have a pressure regulating station and there's 15 alarms going on at that pressure regulating station, what do I want to know?
What caused the alarms?
Right. Said a different way, what is the operating upset causing all those alarms?
Right.
The other thing I want to know is, how severe is the upset? Because if I've got multiple of those going on, I want to know which one to address first. So in this case, I want data around an operating facility, what we would call an area of operation. I want data around an operating facility, and I want that data contextualized. I want you to tell me, through how you process all those alarms, how severe is the upset? And that's going to tell me how quickly I need to get on it versus other things that might be coming at me from a workload perspective. So in that case, I need it right now, I need it very accurate, and I need it contextualized, right? So that's not as much about data collection as it is about processing that data once I have it collected. Is this making sense?
Yeah.
Right.